Welcome to Demystifying Math. In this lesson, we're going to be discussing transformations of the graph of the sine function. In the previous video, we saw the basic sine graph and how to graph that. So if you need to review it, go back to graphs of sine functions. Okay, so we have our basic sine graph, our curve, where we have on our x-axis our angle measures in terms of radians, and our y-axis we have the ratio for the sine. Now we took those values from the unit circle, where we started off with an angle measure of 0, and our ordered pair at that point on the unit circle was 1, 0. Recall that the x values are going to represent your cosine, and the y values are going to represent your sines. So the sine of 0 is 0. The sine of pi over 4 is square root of 2 over 2, which is approximately 0.7, so it would be in here somewhere. And then so on for pi over 2, we have the ordered pair 0, 1, so our output for sine, or our ratio for the sine of pi over 2 is 1. So with this parent function, our domain is all reals. We can put in any angle measures that we want. We can do it in radians, we can do it in degrees, and we can put in any of them. Remember that once you've gone around the unit circle once, you've gone 2 pi. So that means that you have completed a period within 2 pi units. But after that, all the angle measures are coterminal with the ones that we already have. So as the graph continues to go around the circle, your wave function is going to continue to go on in the same pattern. The range of the sine x function is from -1 to 1. Remember that all the ratios for the sine of x are on the unit circle. Since the unit circle has a radius of 1, all the numbers other than the corners are going to be less than 1 for their x and y values. The period is 2 pi. And now we also want to talk about the amplitude of the function. And the amplitude is half the distance from the lowest point to the highest point on the graph. In this case, our lowest point is at -1, and our highest point is at +1. So that means the distance from the lowest to the highest is 2. We want to take half that distance and call it our amplitude. So in this case, our amplitude is 1. Okay, let's get into some of the transformations. What we want to do first is have an amplitude change. So we have the function y equals 4 times sine x. So we're taking our sine value, which is a ratio, and multiplying it by 4, which is causing a change vertically to our graph. It's actually causing our graph to stretch vertically. But let's go ahead and plug in our critical points and see what our outputs are. So plugging in 0 into the y equals 4 times sine x. Remember, the sine of 0 is 0, so we're still going to get out 0. At pi over 2, the sine of x is 1, so our output is 4. At pi, we're back to 0, and at 3 pi over 2, the sine of 3 pi over 2 is -1, so our output will be -4. And at 2 pi, we're back to 0 again. So with just these 5 critical points, you should be able to get a sketch of your graph. So go ahead and plot these points on a grid, and then connect them with a smooth curve. Then come back to the video. Okay, so you should have gotten a graph that looks similar to this one. And I just plotted them on the positive part between 0 and 2 pi, but you could continue the curve over to -2 pi if you needed another period of the graph. But from 0 to 2 pi is going to be one complete period, then the entire graph is going to repeat because those will be your coterminal angles. Okay, so looking at your graph and thinking about what it looked like before, before our amplitude went from -1 to 1, our height went from -1 to 1, and our amplitude was 1. In this case, our lowest point is at -4, and our highest point is at +4. So that distance is 8, half that distance is 4, so your amplitude is 4 in this case. So it's causing a vertical stretch of your graph. Anytime the coefficient of the sine of x is greater than 1, you're going to have a vertical stretch. If the absolute value of that coefficient is between 0 and 1, it's going to shrink your graph down toward the x-axis. Now our domain is still the same as it always has been. We still can plug in any numbers that we want. But our range is a little different because we're going from the lowest point at -4 to the highest point at +4 this time. Our period is still pi, and our amplitude is 4. Okay, now we're going to do a reflection over the x-axis. So we're going to take that 4 sine x and make it a negative 4 sine x. That negative in front is going to cause our graph to flip over the x-axis. Now we're going to plug in our usual critical points. So looking at 0, our output is still 0. At pi over 2, we're getting out negative 4 because the sine of pi over 2 is 1. At pi, we're back to 0. And at 3 pi over 2, the sine of 3 pi over 2 is negative 1, so negative 1 times negative 4 is going to give us positive 4. So you can start to see the flip just by looking at the 5 critical points. Now take a minute and go ahead and graph your points and connect it with a smooth curve. You should know that it's going to look like a wave, so you should kind of get a feel for what your graph will look like. Okay, so you should have gotten a graph that looks similar to this one. Notice that with the other one we had the point at pi over 2 was at positive 4, now it's at negative 4, so it flipped over the x-axis. Our domain is still all reals. We still have a vertical stretch by a factor of 4, so our range is going to be from negative 4 to 4. And our period is still the same. Our amplitude is 4. Okay, let's go ahead and do a vertical shift. In this case, we're going to shift our graph down by 2 units. But let's go ahead and plot our points to see what happens to the graph. Okay, so we're still using the same critical points. So at 0, if we plug in 0, the sine of 0 is 0. So we're taking 4 times 0 minus 2, which gives us negative 2. At pi over 2, our sine is 1. So we have 4 minus 2, or positive 2. At pi, we have a 0 again, so we're back at negative 2. At 3 pi over 2, that sine is negative 1. So we have negative 4 minus 2, which gives us out negative 6. At 2 pi, we're back to negative 2. Okay, so go ahead and plot your points and draw your curve. You should get a curve that looks similar to this one. Now notice that we have the highest point at positive 2 and the lowest point at negative 6. So the distance between positive 2 and negative 6 is 8. So our amplitude is still going to be 4. Notice that the coefficient of the sine of x is 4. So it's still representing the amplitude of the graph. The 2, we subtracted 2 from the function, so that caused us to shift down. If we had added to the function, it would have shifted the whole graph up. So our domain is still all reals. Our range is going from negative 6 to negative 2. Always give me the lowest to the highest in that order. Your period is 2 pi, and your amplitude is 4. Okay, in the next lesson, we're going to be doing some horizontal transformations of the graph. Thank you for tuning in to Demystifying Math.